This tutorial describes how you can process multi-channel images in the Baxter algorithms. To demonstrate this, I have a small data set with 3 images, and these images come from fluorescently stained muscle sections, where red is laminin, which marks the extracellular matrix, the space between the muscle fibers. Blue marks DAPI, or is DAPI, which marks the nuclei, and green is green fluorescent protein, which comes from transplanted cells from a different GFP positive animal. To open images like this in the Baxter algorithms, they need to be in a different format, where the different fluorescent channels have their own images, or single channel TIFF images, and all of the images associated with the same field of view should be in the same folder. There should be one folder for each field of view, just like this. And to open a dataset like this in the Baxter algorithms, you go to File, Open Experiment, and you find the folder. And now we get something that we don't want, because the program assumes that the different images are time points in a time series, and therefore we need to tell the program that the images are different fluorescent channels. And we do this by going to Settings, we set the level to Advanced, and then we specify the settings called channel names and channel tags. So the channel names is just what we want to call the channels. In this case it's DAPI, GFP, and laminin. And then the tags are parts of the file name that are specific to the different channels. In this case it's CO1, ZO2, CO3 for DAPI, GFP, and laminin. And I separate both the names and the tags by colons. Then I press save, and now I get something where I have 3 different channels, but they have the wrong colors. So I go to Set Fluorescence Display, which is also an advanced setting, or an advanced option. And here I specify that I want DAPI to be blue, GFP to be green, and laminin to be red. And now I can also select which channels I want to display. That's something you can do in any player in the software. So if we look at the GFP channel in isolation, we can set upper and lower thresholds for the fluorescence, or for fluorescence display, so we can hide the background. This won't affect the processing later on, it only affects the display. But everything below this threshold will be displayed as black, and everything above the upper threshold will be displayed as saturated green. In this case I don't think we need to change this, but it was nice to get rid of some of the background. And we can do the same thing for the laminin channel, remove some of the background. and make it a little brighter. And as I said before, this won't affect any of the processing, it's just a way to get a nicer image to look at. Sorry, I should. And here I will just remove some background. So this looks a little bit nicer, and I press apply to all sequences to apply it to all of the images in the experiment. And now we have images with multiple channels in the right colors. But if you have exported RGB images from the microscope, there's a way to convert these images into single channel TIFF images like these ones, so that you can open them in the program. And first I'll just remove this experiment. You can do this by pressing convert merged images, and then you open the folder with the RGB images in, and then you specify what you want the different channels to be called. So red was laminin, green was GFP, and blue was DAPI. And then you can choose between merged images and tiled images, where you have the red, green and blue channels in 3 corners and then the merged image in the lower right corner. But these images are less common than the merged RGB images. And once you've entered this, you press process, and then you can open the experiment in the main program. And the files are in the same folder as the RGB images. And all of the channel colors and the channel tags have been set appropriately. And this is what the converted folder looks like. You have the settings file, and you have the 3 folders with single channel TIFF images along with the original images.